Today we are discussing about array implementation of polynomial addition. The main contents that included in this presentation are: first one is what is a polynomial, next one is polynomial representation in array, third one is polynomial addition. Now let's discuss about what is a polynomial. A polynomial is defined as an expression which is composed of variables, constants and exponents that are combined using the mathematical operations such as addition, subtraction, multiplication and division. And here is an example: 4x square plus 1y minus 1. And here 4 and 1 are coefficient, 2 is exponent, x and y are variables, plus and minus are operators and 1 is the constant. And there are some things to consider in polynomial. First one is notation. The polynomial function is denoted by p of x, where x represents the variable. For example, p of x is equal to x square minus 5x plus 11. If the variable is denoted by a, then the function will be p of a. Next one is the degree of a polynomial. The degree of a polynomial is defined as the highest degree of a monomial within a polynomial. Here is an example: 3x square plus 5x plus 19. The degree of the polynomial is 2. And the last one is terms of a polynomial. The terms of a polynomial are the parts of the equation which are generally separated by plus or minus signs. That is, here is an example: p of x is equal to 2x square plus 3x plus 4. And the terms in this expression are 2x square, 3x and 4. Let's discuss about polynomial representation in array. There are three methods. First we discussing about the first method. One-dimensional array is defined and coefficient is added to the array and the exponent is indicated by the index value. Here is an example: 2x square plus 3x plus 1. And the representation is like this. 1, 3 and 2 are the coefficients that are stored in the array, and the corresponding exponents are indicated as index values. Now let's discuss about the second method. Here we use a single dimension array to represent the polynomial, but we store both the index and coefficient in a single array itself. Here is an example: 4x raised to 6 plus 10x raised to 4 plus 12x plus 8, and the array representation be like this. 4 is the number of terms in the polynomial expression and 6 is the exponent of corresponding coefficient 4. Last and third method. Here we use two-dimensional array to represent both coefficient and exponent in a polynomial. Here is an example: 8x cube plus 3x square plus 2x plus 6, and the array representation be like this. Now we discussing about polynomial addition using array. Here we take two polynomial expressions as x1 and x2. x1 is equal to 3x plus 5x square plus 7x cube, and x2 is equal to 10x plus 3x plus 5x square. Before going to addition, first we want to identify the degree of both polynomials to find the degree of the added resultant polynomial. Here the degree of x1 is 3 and the degree of x2 is 2. So degree of x3 is the maximum of degree of x1 and x2. So degree 3 is taken for polynomial x3. Next we represent the polynomial using array. Now we going to add these two polynomials. Next we represent the polynomials using array. Now we going to add these two polynomials. In x1 there is no coefficient for exponent with the index 0. And in x2 there is 10 as coefficient for exponent 0. Therefore in x3 0 plus 10 is equal to 10 as coefficient for exponent 0. And next we considering index or exponent 1. In x1 there is 3 as coefficient and in x2 there is 3 as coefficient. So 3 plus 3 is equal to 6 as coefficient in x3 with the corresponding exponent 1. Next we considering 2 as exponent. In x1 there is 5 as coefficient corresponding to 2 exponent, and in x2 there is 5. Therefore 5 plus 5 is equal to 10 as in x3. And next we considering 3 as exponent, and in x1 has 7 and x2 has 0. Therefore 7 plus 0 is equal to 7 in x3. So the added resultant polynomial x3 is equal to 10x plus 6x plus 10x square plus 7x cube. So this is for today's presentation. Thank you.